How do you install an RV air conditioner? Today, I'm going to show you how to take out the older existing RV air conditioner, and I'm going to show you how to put in the newer inverter heat pump air conditioner for your RV. I'm also going to show you the cost comparison of how much does it cost for me to power this older conventional traditional non-inverter RV air conditioner versus the newer heat pump inverter RV air conditioner. We've got a new RV air conditioner right here. It uses the new A2L refrigerant, and it's also got inverter technology in it. So it's a lot more efficient. I'm excited to unbox it, show you what's inside, and start this RV air conditioner install. You're watching Taddy Digest. This is a HVAC tips for technicians / homeowners video. I'm Tad. Let's get started. So what's inside the package? We've got our ceiling assembly right here. This is what's going to mount indoor. And then we've got our rooftop part. And this is what's going to mount on top of the RV or your camper. Then we've got our air duct sponge right here. Looks like some type of insulation or foam. We got the most important part, our user manual. Definitely read the manual. Then we've got a really nice holder and a remote control. So this is a wireless remote controller you get to operate this unit. And then, last but not least, a very important piece, we've got our 4 bolts for our ceiling assembly. That's what's contained inside the package. We're going to take the outdoor rooftop cover off of this outdoor part so that we can actually see, is this a heat pump? We got the cover off. Let's see what's inside. First thing I notice, reversing valve. So this is a heat pump. This will do heating and cooling. We've got a rotary compressor mounted on its side. That is interesting. It's got some labels for warning, A2L refrigerant. Looks like it's R32. We've got 2 different fan motors. Usually what you're going to see in an RV air conditioner like the one I'm going to show you, we got one central fan motor that's for the indoor and outdoor. And it's got a blade connected to each side because it's got a double shaft. We don't have that. We've got an outdoor fan, which is very interesting, and we've got an indoor fan. So I'd say this is much better. Then the last thing that tells me, well, first thing was heat pump reversing valve, rotary compressor, UVW, 3-phase. How can it be a 3-phase compressor unless it has inverter board? So we do have an inverter board, and you can tell it's got a heat sink. If you look at the schematic, you'll see this is impressive. I got a coated coil, it looks like. Very well put together, good manufacturing, and I'm excited to put this in. I'm going to take the larger part of this unit and go ahead and put it on top of the roof. And I'm going to show you how I'm doing that. So I'm taking an extension ladder and I'm taking a piece of 2-inch PVC and putting it on the extension ladder. And then I'm putting the unit back in the box, and then I'm taking a strap and I'm strapping it around the box and then tying a rope to that strap. So this is the way I'm going to be able to pull from on top of the roof this unit. Let's go. This rooftop unit is around 100 pounds. So if you're pulling this up on the roof by yourself, it may be a little tough. You may need to get another person to help you so it's easier. All right. All right, there we go. That's what I'm talking about. This is the indoor part for the RV air conditioner. We're going to take this out first, but before we can actually start the installation process, before we can remove the existing old RV air conditioner, safety first. We got to find out where the breaker is. We got to turn that breaker off and then check and make sure we don't have power. So we've got the filter out of the old existing indoor unit. We've got the power that comes in. You can see there's a 12-2 Romex wire. And I'm going to put my NCV meter right here, my non-contact voltage detector, up to that wire that powers this RV air conditioner. You can see we got power. So we got to take care of that. And you can hear it running. As soon as we turn the breaker off, we'll know that this air conditioner no longer has power because we'll hear it shut off. Here's the air conditioner. Glad it's labeled AC. 20 amp single pole breaker. Turn it off. Now using the NCV meter, we see it's not beeping, indication there's no power. Let's take our Phillips screwdriver or our Phillips bit in our drill, and let's take the 4 screws that hold the cover for this electrical box out. That way we can actually use our meter with leads to test, because I believe in safety first. So here's our wire. Here's the ground, the white and the black. Now we're going to take these wire nuts off and actually test with our meter. All right. Meter on volts AC. Taking both of my leads here, going from the white to the black, which is line and neutral. And we have nothing, so we're good, see? I'm just kidding. All right, loosened up the Romex connector, and now I'm just gonna pull the wire out that powers the RV. Next, take my Phillips screwdriver, take out these 4 screws that hold this cover to the ceiling. This is our ceiling assembly right here. And we got those 4 screws loosened up, so should be able to take this off the wall. No, we can't, because it looks like we got 2 more screws right here, but we got some covers we got to take off. Loosening up these other 2 screws. Had to take those covers off to get to them. And there it is. That is beautiful. Did that get you? Oh gosh.
Soaked my foot.
We got the cover off. We got the power disconnected. Now we got to take out the 4 bolts that go through the ceiling of this camper and connect the indoor and outdoor unit. And they're 3/8. So I swapped out that Phillips bit with a 3/8 bit. There's 2. 3. Oh, that one went in at an angle. All right, 4. Here's the 4 bolts that we took out. Now we're going to take this piece and remove it. Oh yeah! And there it is. Now we should be able to take out the outdoor unit. If you have an RV and you don't have a vent hole, then how big does a vent hole need to be? If you have an RV and you have an existing air conditioner, will this RV air conditioner fit yours? It has to be 14 1/4. Looks like we're at 14 1/4 right here. And then we're at 14, it looks like a half, 14 1/2. So yes, this will work. 14 1/4 by 14 1/4 is minimum vent hole opening that you need. Now that we know that, let's go on the roof. This is the old existing rooftop unit. Let's take this cover off. You can see the cover's been damaged, so that won't hurt it. You can see we've got our compressor here. We do have a reversing valve, so this was a heat pump as well, so that's cool. Noticeable differences though between this unit right here and the new unit. You can see how there's a lower profile with the new unit. I like that. So definitely more aerodynamic. Now that we've got the unit loose right here, we can go ahead and just remove it and take it off. See ya! Hey guys, we got the old unit off. Now let's put the new one in place. Next step, remove everything from the surface where that rooftop unit is going to be placed. If you've got some type of caulking that you've got to remove, then get some type of device or tool that you can use to scrape without damaging the roof. Once you get the surface cleaned, make sure that there's nothing inside the hole that needs to be removed. Now that we've removed this, we're not going to use any silicone. We don't need any type of sealant because this unit comes with a gasket. Let me show you the gasket. Now, as you can see, we've got a gasket that we did not have to put on. I love this part of the install process, not having to put a gasket in place. But this is where you want to know that this gasket's here so that you don't damage that gasket, right? If I wouldn't have put this back in the box and I would have tried to lean this on the extension ladder, we may have damaged this gasket. So be careful not to damage. Now that we've got it up here, no gasket installation needed. We just put this in place. Right here we've got the bottom side of this unit, and you can see the max circuit protection is 25 amp breaker. So you could use a single pole 25 amp breaker or single pole 20 amp breaker as your breaker size. Then you can see R32, and it holds 19.75 ounces. So we're about 1.3 pounds for the total charge. Then you can see heating and cooling capacity. We've got a range of 7,000 upwards of 13,000, and then our current. So if you want to take a moment, pause the video, take a look at this. You can go to www.turbo.com. You can pick this unit up. You can use my discount code. I got a discount code, Taddy Digest. You can get around $100 off. Whenever you're lowering this unit down, you want to make sure the gasket matches with your vent hole. You want to make sure that the wires that feed to the indoor part, that they are routed down through that vent hole. And then you can see there's 4 bolt holes, and those are in between or inside your gasket area. You got to make sure you can see those from inside the RV or camper. So there's our wires. Now we're going to make sure that it's lined up. There it is. Perfect. I mentioned that this has a lower profile, but let's see what it is. So it looks like it's around 11 inches tall. Then it's around 42, 43 inches long. And then as far as width, it's around 28 inches wide. Those are the dimensions. Let's go mount the indoor unit. Now we're going to plug in the wires that come from our outdoor unit to the indoor unit. We're going to plug those in. We're going to take and put our air duct sponge in place. Where does it go? There's 2 holes on the fixing plate. One is larger, that's the return, where the filter will be, and then one is smaller, and that is the supply. And you want to take the appropriate sponge, which there are 3, and they each have a certain thickness. I'm going to take the larger one, and I am going to place it right here, like this, where the holes line up. And just like that, it's going to set in place. And whenever we put this fixing plate up against the hole, we can see that's where the block is going to be, that little sponge. And then we've got our bolt holes. 1, 2, 3, 4. Every roof thickness is not the same. I'm not going to use just one of these sponges. I'm going to stack these 3 on top of each other. I'm taking off this adhesive tape here and putting it in place. Now I got all 3 sponges together. It's going to reach the supply trunk. It's going to make a nice tight seal because all roof thicknesses are not the same. You may need to use 1, 2, or all 3 like I did. But now when we put this up and it fits into the hole, then we don't have our return air and supply air mixing. So if you don't use this, your return air and supply are going to be mixing. Unit's probably going to freeze up. It's not going to work properly. It's not going to perform as it should. Now I'm going to take and feed all the wires through this larger hole, which is the return. Now I can plug them all in. Don't forget the power. There's the power. And moving on up. That looks pretty good right there. Beautiful. I'm not going to tighten those all the way up yet. All right, so we're going to wire up the power now. So we remove this cover, this little plate here. That's a cute little plate, isn't it? And you can already see we've got our black wire, which is our line. We've got our white wire, which is our neutral, and our ground wire, which is our ground, of course. And I love the fact that they have a, I'm going to unscrew this so you can see it. They have a cable gland in here. So you have some type of connector that you route your wire through. That way it's not touching the metal for the enclosure. So that's nice. So we are going to take this cable gland. We're going to run our wire through that cable gland like this. And then our wire is going to go. First we got to take that connector off, of course. Okay, and then we're going to take and feed our wire into this enclosure here, and then have it come out so we can see it and get to it. And then we're going to put our connector on that wire, and then we're going to tighten up that connector. I'll get this tightened up, and then we'll wire nut those wires. So you can see I've wired everything up. Now I'm going to put this plate on, this cover. It was pretty easy, black to black, white to white, and green to ground, or bare wire to the ground. Now I got that in place. There's two white plugs right here that you plug in on this box, and then we've got this one wire here that goes to the display, and then one of them says freeze sensor. So once it's wired up, then we put the panel in place. So we're going to do that now. Now that we've got the display wire run through the return hole, we're ready to take and put this cover on that contains the filter. So what we're going to do is we're going to line this filter up with the hole right here, and we're going to route this display wire through this hole right here. So we got that routed through. Looks good. Make sure you get it in place. Your screw holes will line up when you do, right there. Now we got 4 screws that come with the unit, and they're in the same package that the 4 bolts were in. And you're going to put these 4 screws, and that will connect that cover to that plate. 1, 2, 3, and then 4. Now we're going to install the last cover. What we're going to do here is we are going to plug in our display. You got to plug in your display because this display is also our receiver. We've got a transmitter, which is our remote, and that communicates with our receiver or display. We got 2 hooks. Go up, and then it says push once you get it up. So push. Okay, wow. So we can take this off by pushing, and then we can take our filter out. We can wash it and put it back in. Now that we've got everything connected, we're going to turn the power back on, and we're going to run it through some tests. Now let's use the wireless remote controller, and let's turn the unit on, and let's choose a mode. So push the power button, push the mode button. We're not going to do auto, which is heat and cool, or snowflake, which is cool, or looks like water droplets, which is dry mode, or the fan blade, which is just fan mode. We're going to do the sun, which is heating. Turn it up to 86 or 85. Right now it's not running. Why is it not running? Because in heat mode, the compressor will come on first, and then the coil temperature will reach a set point, whether it's 90 or 99, and then the indoor fan will start to blow because we don't want a cold draft. Now, let's get our dual induct cyclometer and check the supply air temperature. So right now the compressor is ramping up. It's not blowing any air out of the vent. It is about 50 or 60 degrees in here. Take a look. It is 52, 53. Yeah, 53 degrees. Now, we should have at least a 20-degree split. So if we're checking this is the return and it's 53, then we should have at least 73-degree air coming out of our vent. Let's wait till the fan kicks on, and then we're going to check that supply air temperature. All right, fan just kicked on. Let's put the telescoping probe in the supply air with the dual induct cyclometer, and it looks like it's blowing 76 degree air, 75. So really nice. That means we've got about a 22-degree split, and it feels warm. That's great. So that means if it was 70 degrees in here, it's going to be blowing out at least 90 degrees, and it's quiet. I like it. So now let's measure the amp draw and see exactly how much electricity this unit consumes when it's running. Now let's take our meter and let's put it on volts AC right here. Then we're going to measure the wire that goes to the breaker. It's right here on top. It's a 20 amp single pole. Let's measure the voltage. It's 122 volts. We're going to use that number here in a minute. Now we're going to take and push the select button. This is going to give us our amp reading, and we're going to wrap the clamp around this wire that goes to the unit. And what does it say right now? We're at full speed and it's 9 amps. So this unit pulls 9 amps in the heating mode, and it's powered by 120 volts. Now, how can we tell how much this is going to cost to operate per month? Let me show you. Now we're going to use our calculator, and we're going to calculate how much this costs to run per day or per month. So we're going to take the 123 volts, and we're going to times it by our amperage, which was 9. This gives us our kilowatts. Then we're going to take and divide the kilowatt by 1,000 to get kilowatt hours. So it's 1.1 kilowatt hours. Then we're going to take that and we're going to multiply it by what our electric company charges us for a kilowatt, which around here, it's around 10 cents. 10 cents per kilowatt hour. So now we take 1.1, we times that by 10 cents, and then we times that by 1 hour. 1 hour is 11 cents to operate this machine. Now the average for runtime per day for a heat pump inverter is around 6 to 8 hours. So we're going to take this and we're going to multiply it by 8. So 1.1 times 10 cents times 8 hours equals 88 cents. So 88 cents per day, and then we're going to take that and we're going to multiply that by 30 per month. So to run this machine for 8 hours a day for 30 days, it's going to cost us $26. That is cheap. So this uses 1,000 watts when it runs. That is very efficient, especially when it's going to output a supply air temperature that's 20 degrees warmer than the room air temperature. Let me know what you think in the comments. Very cool. The RV heat pump has been running for about 10 minutes. You can see it's now 71 degrees. Right here's your display, and it displays room temperature and set temperature. I'm going to put my telescoping probe in here, and you can see that now it's 71 and it's blowing out 95, 96, 97, wow, 98. So we've literally got 100. Wow, that's awesome. That's just the heat pump. 101. So we got a 30-degree temperature split. This really does heat really well. Now let's turn it off, and you can use an app. You don't have to just use a wireless remote controller. Check out the manual. There's a QR code and there's an app you can download. You can control this RV heat pump from anywhere, not just your home. Here's the other RV air conditioner. Most RVs have two on top of the roof. This one is the conventional non-inverter. It just does cooling. It's not a heat pump, so it doesn't have heat and cool modes, not like our turbo heat pump. So let's test out the cooling because we're not going to use the gas furnace, and I'll show you what I'm talking about. Here's our thermostat that controls this RV air conditioner for the cooling mode and the fan. And it controls the gas furnace, which is propane that heats this RV. So we're going to turn it on, and we're going to be able to see that there's going to be a difference in noise level. This conventional unit is much louder than our smooth operating turbo. So turn it on, turn it to the cooling mode, turn it down to 55, and then we're going to measure the amp draw. That is loud. It's just the fan. The compressor hasn't come on yet. Should come on in a second. You should hear it. Nurr.
One eternity later.
There goes our compressor. Now let's measure the amp draw. Now let's see what this conventional RV air conditioner is going to cost to operate per day and per month. So take your meter, turn the dial to volts AC. We've got our breaker here. It's a 20 amp single pole breaker. Let's measure the voltage. Measure the voltage, 120 volts. Now we got that. Let's measure our amperage. Wrap in that clamp around the wire. It's 12.5, 12.6 amps. So now we know that, so we'll do 12.5. Now let's use our calculator. So we take 120 volts multiplied by the amperage, 12.5, 12.5. Then we get 1500 watts. Then we divide that by 1000, which we know what it's going to be. It's going to be 1.5 kilowatts hours. So then 1.5 times by what it cost for electricity here, 10 cents. And then times that by, let's say this straight air, this cooling RV air conditioner runs for 8 hours. So 8 hours is 1.2. So it's $1.20 to run this for 1 day, 8 hours. Then we multiply that by 30. So that gives us 36. So to run this inverter, it's going to cost us $26. To run the non-inverter, it's going to cost us $36. So it's going to cost us $10 per month more to run the conventional air conditioner than it is the heat pump inverter. So you're going to save money, and then when you calculate this over a whole year, then that's at least $100. So you are going to save some money. This unit is way more efficient than the conventional, the traditional, and we can see that with the numbers here. If you need an RV heat pump like this one, go check out turbo.com. Use my discount code TaddyDigest and you'll save 10% upon purchase. Hope you enjoyed the video. I hope you liked it. If you did like it, hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. If you got a question, remember questions can lead to new content, but if you don't have a question, that's okay. Let me know who you are and let me know where you're from. You've been watching Taddy Digest. This is HVAC tips for homeowners/technicians. I'm Tad, and I'll keep you cool if you let me.